Hello again, it's Kim Schmidt, continuing here with the fourth last video section of Cloud and Data Metamorphosis that augments my Pluralsight course, Serverless Analytics on AWS, highlighted with a blue rectangle and pointed to by a blue arrow. Under the blue arrow is the link to that Pluralsight course. Video number 3, Cloud and Data Metamorphosis, is part of a larger video series entitled AI, ML, and Advanced Analytics on AWS. Let's quickly overview what we just learned in part 3 of Cloud and Data Metamorphosis and quickly introduce you to the topics in this part 4 of Cloud and Data Metamorphosis. In part 3, I covered the following: serverless architectures, AWS Lambda, AWS's Serverless Application Model, or SAM, all about AWS's containers, AWS Fargate, and Amazon Elastic Container Registry, or ECR. In part 4, I'll cover the evolution of data analysis platform technologies. Serverless analytics, a better, faster way to transform data. AWS Glue and Amazon Athena, clusterless computing, and an introduction to Amazon S3 data lake architectures. Continuing on how technologies have evolved, in this section, I'll cover the evolution of data analysis platform technologies. The timeline on this slide shows the evolution of data analysis platform technologies. Around the year 1985, data warehouse applications were the platform of choice. This consisted of multi-core CPUs and networking components with improved storage devices such as network attached storage or NAS appliances. Around the year 2006, Hadoop clusters were the platform of choice. This consisted of a Hadoop master node and a network of many computers that provided a software framework for distributed storage and processing of big data using the MapReduce programming model. All the modules in Hadoop are designed with a fundamental assumption that hardware failures are common occurrences and thus should be automatically handled by the framework. The core of Apache Hadoop consists of a storage part known as Hadoop Distributed File System, or HDFS, and a processing part, which is MapReduce. Hadoop splits files into large blocks and distributes them across nodes in a cluster. It then transfers package code into nodes to process the data in parallel. You can see logos for many of the frameworks that Hadoop commonly runs on, including Spark, HBase, Presto, Hue, Hive, Pig, and Zeppelin. Everything you see beyond this point on the timeline are AWS technologies. Around the year 2009, decoupled EMR clusters were the platform of choice. EMR stands for Elastic MapReduce, which is Amazon's managed service for Hadoop. The core of Apache Hadoop consists of a storage part known as HDFS, but shown here using Amazon S3 for EMR file storage, or EMR-FS, and a processing part, which is a MapReduce programming model. This is the first occurrence of compute and memory decoupled from storage. Hadoop again splits files into large blocks and distributes them across the node in a cluster. It then transfers package code into nodes to process the data in parallel. This approach takes advantage of data locality, where nodes manipulate the data they have access to. This allows the data set to be processed faster and more efficiently than it would be in a more conventional supercomputer architecture that relies on a parallel file system where computation and data are distributed via high-speed networking. Around the year 2012, Amazon Redshift Cloud Data Warehouse was introduced, which was a very transformative data analysis platform technology for so many awesome reasons. What the diagram on the timeline shows under the year 2012 is difficult to read, so I'll explain it to you. Directly under the written year 2012 is a set of 3 sample client apps that talk to the leader node and receive information back from the leader node via ODBC or JDBC connections. Under the leader node are multiple compute nodes with multiple node slices that have two-way communication with the leader node, as well as a variety of data sources shown by the 4 icons on the bottom of that image. Today, the data analysis platform technology of choice is serverless and clusterless computing via an Amazon S3 data lake using AWS Glue for ETL and Amazon Athena for SQL, both having two-way communication with the underlying S3 data store. Since data is changing, so must the analytics used to glean insights from any type of data. Today, data is captured and stored at petabyte, exabyte, and even zettabyte scale, and analytic engines must be able to keep up. Some samples of new types of analytics include machine learning, big data processing, real-time analytics, and full-text search. Amazon S3 data lakes are ideal for on-demand analytics. The services you see on the right side of the image are all serverless. You have zero infrastructure to manage and zero administration. You never pay for idle resources, only for the time the services are used. Analytics in an Amazon S3 data lake automatically scales to handle any load based upon usage needs, and there's high availability and fault tolerance built in. The AWS services shown on the right of the image will be elaborated upon in the next video, which is video number 4 on Amazon S3 data lakes. At this point, I'm excited to share with you the 2 innovative, cutting-edge serverless analytics services provided by AWS. Amazon Athena and AWS Glue. These services are not only cutting edge because they're state-of-the-art technologies, but also because they're serverless. Having a cloud-native serverless architecture enables you to build modern applications with increased agility and lower cost of ownership. It enables you to shift most of your operational and infrastructure management responsibilities to AWS, so you can focus on developing great products that are highly reliable and scalable. Joining the AWS services of Glue and Athena is the Amazon S3 Data Lake platform. S3 data lakes will be covered in the next video. Data preparation is by far the most difficult and time-consuming tasks when mapping disparate data types for analytics. 60% of the time is spent on cleaning and organizing data. 19% of the time is spent collecting data sets. The third most time-consuming task is mining data for patterns. The fourth most time-consuming task is redefining algorithms. The fifth most time-consuming task falls under the broad category of other. The sixth most time-consuming task is building training sets for machine learning. The moral of this story is there has to be a solution to decrease the time spent on all these tasks. Well, there is, and I can't wait to share it with you. I'll begin in the next few slides and then elaborate more in the next video. AWS Glue solves the business problems of heterogeneous data transformation and globally siloed data. Let's look at what AWS Glue is. There's an AWS Glue data catalog that provides one location for all global data. There's AWS Glue crawlers that crawl your global data sources, populates the Glue data catalog, and keeps the data catalog in sync with all changes to the underlying data source, no matter where in the world they're located. Glue identifies data formats and data types. It has built-in error handling. AWS Glue jobs do the transformations on your data, and you can schedule jobs to run either based on events or on a time schedule. AWS Glue ETL is one of the transformations that can be done with AWS Glue, but there's many other data transformations that are built into Glue. Monitoring and alerting are built in, and AWS Glue eliminates dark data. Amazon Athena solves the business problems of heterogeneous data analytics and gives the ability to instantaneously query data without ETL. Let's look at what Amazon Athena is. Amazon Athena is an interactive query service. You query data directly from S3 using ANSI SQL. You can analyze structured, semi-structured, and structured data. Athena scales automatically. Query execution is extremely fast via executing queries in parallel. You can query encrypted data in S3 and write encrypted data back to another S3 bucket. And you only pay for the queries you run. I'll now touch on data architecture evolution in regard to Amazon S3 data lakes. Serverless architectures remove most of the needs for traditional always-on server components. The term clusterless means architectures today don't need 2 or more computers working at the same time. Thus, these services are both serverless and clusterless. AWS Glue, Amazon Athena, and Amazon S3 are the 3 core services that make AWS data lake architectures possible. Under Amazon Athena's covers is both Presto and Apache Hive. Presto is an in-memory distributed SQL query engine used for DML or data manipulation language, like create, select, alter, and delete. It can query data where it's stored without needing to move the data into a separate analytics system. Query execution runs in parallel over a pure memory-based architecture, with most results returning in seconds. It can perform interactive data analysis against gigabytes to petabytes of data, and it's ANSI SQL compatible with extensions. Hive is used to execute DDL statements, or data definition language, a subset of SQL statements that change the structure of the database schema in some way, typically by creating, deleting, or modifying schema objects such as databases, tables, and views. It can work with complex data types and work with a plethora of data formats. It's used by Amazon Athena to partition data. Hive also supports MSCK repair table, or alter table recover partitions. MSCK repair table recovers partitions and the data associated with partitions. AWS Glue builds on Apache Spark to offer ETL-specific functionality. Apache Spark is a high-performance, in-memory data processing framework that can perform large-scale data processing. You can configure your AWS Glue jobs and development endpoints to use the data catalog as an external Apache Hive Metastore because the data catalog is Hive Metastore compatible. You can then directly run Apache Spark SQL queries against the tables stored in the data catalog. Using Spark SQL, you can use existing Hive Metastores, SIRDAYs, and UDFs, or user-defined functions. Either way, serverless architectures provide all the benefits of cloud computing, but with considerably less time to create, maintain, monitor, and more, and at an amazing cost savings. The quote on this page is from Charles Darwin, English naturalist and geologist. It reads, "It is not the strongest of the species that survives, nor the most intelligent that survives. It is the one that is the most adaptable to change." I thought it interesting that essentially the same quote that came from Charles Darwin is today being reiterated in another quote by Jeff Bezos, Amazon founder and CEO. It reads, "What's dangerous is not to evolve." That's the point I hope you discovered while watching this video series number 3. Businesses and IT professionals today have to evolve because everything is changing so fast, and you and I need to evolve to newer technologies at a more rapid pace than ever before. So keep up with the course and the video series so that you can evolve with state-of-the-art technologies. This is the end of Multi-Video Series 3 in the parent multi-video series, AI, ML, and Advanced Analytics on AWS. In the next video, which will be video number 4, I'll go into depth on just how cool the Amazon S3 Data Lake storage platform is and why it's so cool. I'll also describe how AWS Glue and Amazon Athena fit into that platform. I think you'll be amazed at how these technologies together and other AWS services provide a complete portfolio of data exploration, reporting, analytics, machine learning, AI, and visualization tools to use on all of your data. By the way, every top-level video in this series will end with this slide, with this image on it and the URL at the top. The URL leads you to my book site, where you can download a 99-page chapter on how to create a predictive analytics workflow on AWS using Amazon SageMaker, Amazon DynamoDB, AWS Lambda, and some other really awesome AWS technologies. The reason the chapter is 99 pages long is because I leave no black boxes so that people who are advanced at analytics can get something out of it, as well as a complete novice. I walk readers through step by step in creating the workflow and describe why each service is used and what it's doing. Note, however, that it's not fully edited, but there's a lot of content as I walk you through building the architecture with a lot of screenshots, so you can confirm you're following the instructions correctly. The title of the book that I'm writing is Artificial Intelligence and Analytics on AWS. I'll see you in the next video.